Okay, everybody, welcome. I don't know who's out there because I don't seem to have a chat box up, but welcome to Live Deep Sky Observing. Sorry we're running a little bit late. Some last minute technical issues, which I'm hoping have gone. So at the moment, the telescope is set up and it's aligning. A few connection problems, but hopefully it's getting to the first target that I want to look at tonight. So the telescope we're using, for those who are interested, is a Celestron C9.25. It's a Schmidt-Cassegrain telescope, and it is very similar to one being used on the International Space Station at the moment. It has a hyperstar lens fitted to it, which makes it a very fast telescope. And hopefully that's going to allow us to see quite a few nice images tonight of what's out there. Now, for some reason, the connection has decided not to play fair. So let's see if we can fix that. By the way, it's a really warm night tonight here in Tenerife. I'm sitting up on the roof of the apartment we're staying in. We're on the west coast, somewhere that doesn't suffer too badly from light pollution. So just having a look now to see how we're getting on with finding that first target. And the connection's dropped out again, so it looks like this might not work as well as I hoped it would. Okay, connection's back. Yeah, this was the risk I was worried of. I'm only using a hotspot on a mobile phone to try and carry all this data. I just don't think it's up to it, which is a shame. I'll give it another couple of minutes and see if it does any better. Bear with me, folks. If it doesn't sort itself out in the next few minutes, I think I'll call this live session, and what I'll do is I will record it, and I'll upload it so that you can watch it at your leisure rather than hanging on here. Okay, well, we seem to be getting somewhere. So I'm not sure why I can't see a chat box, so I've got no idea. If anybody's out there, you might be screaming at me saying I can't hear anything or I can't see anything. But I'm afraid I'm not getting a chat box, which I thought it would be getting. So hopefully someone's there and someone's seeing something, because I'm about to show you a live image that we're just getting up now. And this first image is going to be of what we call a globular star cluster. That's the largest one we can see in the Northern Hemisphere. It's called the Great Globular Cluster in Hercules because you find it in the constellation of Hercules. It's also known as Messier 13. That's its number in the Messier catalogue, which is a catalogue of very common and easy to find targets in the night sky. So this globular cluster is a big ball of stars in the sky. It's between 22 and 25,000 light years away. And just for a reminder, a light year is 6 trillion miles. So that's how far light travels in 1 year, 6 trillion miles. This thing is between 22 and 25,000 light years away. So if you're good at maths, 25,000 times 6 trillion miles, that's how far it is away in miles. So it contains several 100,000 stars. Nobody knows exactly how many because they're so tightly packed together. And it's 160 light years in diameter, so it's not a small thing at all. Remembering that a light year is 6 trillion miles, that's 160 times 6 trillion across. That's how big this thing is. It's estimated to be about 11 billion years old. So let's have a look at that now. Switch this over. Okay, so there it is. You should see that there in the center. Globular cluster M13. Loads and loads and loads of stars. And what we're going to do is we're going to do something called live stacking, where we're going to take lots and lots of pictures of this, and it's going to stack these pictures together and give us a vastly improved picture about what we're seeing now. So we should see a bit more contrast and detail. We can see probably that it's still a bit light here. It's not quite fully dark, so the background sky is still a bit bright. But here we go. So we're going to be taking lots of 10-second pictures, stacking them one on top of another. This really does look quite nice in the eyepiece. It looks like you're flying over a city at night, you know, with all the individual little sparkly lights. What you don't see through the eyepiece is the actual detail of the individual stars that we're starting to see here. The center is just a cloudy ball. Originally this was called a nebula. Anything in the sky that wasn't a pinpoint bit of light that looked a bit cloudy or a bit vague was called a nebula. It really needs cameras and telescopes to help us see the detail in these things. So hopefully you can see now we're starting to see more and more of those individual stars. There's even some colour coming out, the bright star to the lower left. You can see there's a nice blue tinge to that, whereas the other stars are pretty yellowy orangey. Colour of stars, of course, tells us their temperature. The hotter they are, the more bluey white they are. The cooler they are, the more orangey red they are. And that also tells us where they are in their life cycle. So hot blue stars are very new stars, very young stars. They're very, very, very energetic, just like people. And as they get older, as they burn through all of their material, they become more yellow, like our star is now, middle-aged, so yellow, and then they get progressively more orange and more red before they die. Someone's kindly messaged me and said they can see the images now too. Well, that's fantastic. We can hear you in Derby. Fantastic. Thank you very much for the message. I wish I could work out how to get the chat box working, but hopefully we'll get that going another time. So yeah, thanks very much for that. That's really, really helpful. So I hope everybody's getting a good look at M13, Messier 13 as it's called. You can see from looking at it that most of the stars are yellowy orange. That's because these are some of the oldest objects in our galaxy. So this does live in our galaxy, the Milky Way as it's called. Almost everything we see in the night sky is within our own galaxy, the Milky Way. There are some other galaxies that we can see, and hopefully we're going to have a look at some of those in a moment. So we'll move on to the next target. So bear with me while I just set the telescope to head off somewhere else. It's the first time I've done this. I'm amazed it's working at all, to be honest. I spent a good few hours today testing everything out, but of course there's only so much you can do without getting the telescope out and actually pointing at that stars and things. So I haven't had a chance to do a run before going for it. So thankfully it seems to be working. So let's have a look here. So we'll have a look at something called M57, the Ring Nebula. Okay, so hopefully you can all see that. There we are. So that's what it looks like in a picture taken probably by Hubble. It's not going to quite look as good as that to us, but we're going to go and see if we can have a look at it. So it's a nebula. And there are a number of different kinds of nebula, but the main two types of nebula are nebulas that give birth to stars and nebulas that result from the death of a star. It seems quite appropriate. This is one that's resulted from the death of a star. And what happens when a common star, a normal star like our sun, dies? When it runs out of material to burn, its atmosphere dissipates. It expands out away from the hot core that's left of the star, and it slowly moves out in space, often creating these round nebulae that are often quite pretty coloured and last for a long time. There are quite a few nebulae in the sky. This is a particularly popular one to look at. As I say, M57. It's visible in a small telescope as a smoke ring. But we should be able to get a bit more detail with it. Looking at it in the camera, if the telescope can work out where it's looking. And it seems to be having a bit of trouble finding this one. Let's try again. That's definitely not it. using quite a small camera here. One of the issues that does give us is it's a small field of view for the telescope to find where it is in the sky, and it certainly failed to find where it is in the sky for this one. So we'll just move it about manually. And give it some bright stars to look at so we can work out where it is again. Okay, and we're off and moving. Let's hope it gets there this time. No, it's off somewhere else. Guys, I'm going to give it one more go, but something's not working properly. It should have gone straight to this after we looked at M13, but it hasn't, and it's been in. It's pointed in 3 different parts of the sky so far, except where it should point. So I'll give it one more try. If that fails, it won't waste any more of your time, and we'll stop the live broadcast and sort it out and record an observing session instead. But we'll just give it one more try. So, well, it says it knows where it is. So let's see. Ah, that's a bit better. If you do get too bored watching me faff about with this, I will be uploading a recording from this, so by all means switch off, tune out, whatever, and it'll be uploaded onto the channel for you to have a look. Let me just bring that up. Okay guys, I hope you're seeing this. As you can see, there's that ring, that lovely ring. It's got a bluish colour, and it's also got this reddish shell of gas around it too. In the very, very centre, you might just be able to make out that little white pinpoint of light. That is the remains of the star that died and caused this nebula. So what's left is what's known as a white dwarf. It's just the burnt out, the white hot solid core of a star. And the atmosphere of the star what was left over is drifting out in this ring shape. Really is quite a pretty object. Obviously an unusual thing to look at when you see it in the telescope or through it in the camera. You can tell immediately it's not a normal thing we would see in the night sky. Very different from looking at a planet or looking at a star. Okay, let's have a try at something else. Okay, thanks Lynn and Paul. You can see the white dwarf. Thank you very much. It's only just visible, but it's certainly there. Well done. Amazing, this is cooking. Okay, let's move on to something else. So that was Messier 57, or the Ring Nebula in constellation of Lyra. It's 2.6 light years in diameter, and it's 700 years old, so not that old. It's only 2,000 light years away, so pretty close. Although remembering a light year is 6 trillion miles, it's still a heck of a long way. There we are. Getting some good colour out of that, which you don't get with the naked eye, of course. Everything we see with the naked eye at night is pretty much in grayscale. So really nice to see some colour happening. Okay, I think we should try and have a look at a galaxy now. And I've got one in mind. It's this one, called M51. Famous galaxy, this one. No, Saturn hasn't risen yet. It'll be about another, where are we? Another 40 minutes, 50 minutes, something like that. To see it well, though, it needs to clear the horizon. So 2 o'clock, 3 o'clock is when it's going to be high in the sky and in clear air. Now, telescope seems to have pointed somewhere else again. Not doing very well at all. Solving. No, you're nowhere near me. You're pointing at the ground. So let's see what we can do with this. Yeah. Exit. It's a lovely night here. There's just a little bit of a breeze coming off the sea, which is just keeping it comfortable. I know it's really hot back at home. That's one of the advantages, I suppose, of Tenerife, surrounded by sea. It never really gets stupidly or uncomfortably hot. Whereas at home, when it's hot, it can be pretty unpleasant. Right, let's have a look over there. Good. Line them out. Go to this time. So, Mount thinks it's found it, and it's checking the stars around the object to see if that agrees with the map it's got in its electronic brain. It's going to try and get it as close to center as it can. Solving failed, tap twice. Okay, so So we should be seeing a galaxy. Now, it is there, but it's going to take the live stacking to bring it out. Just have a preview. Right, there you go. So let's get this live stack. So what we've got here, we've actually got two galaxies together. Collectively, they're known as the Whirlpool Galaxy. Really famous galaxies, great one to look at, but you need really, really good conditions in a telescope to see them clearly. So we're going to have a look through the camera, and we're going to stack again and see just how well we can get to see these. So here we go. What we're looking at there, the core, a pair of cores, two core, the core of each of the galaxies that form the whirlpool. You know what I mean? You know what I'm trying to say. And as we stack these images, we will see more and more detail come out. One's a larger galaxy, a face-on spiral to us, spiral galaxy, and a much smaller one, and they're interacting with each other, so they're actually joined by material between the two of them. So as I say, this is Messier 51, or the Whirlpool Interacting Galaxies. M51, Messier 51, and NGC, which means New General Catalogue 5194. Not easy to remember catalogue numbers like that, so the Whirlpool pairs is good enough. Everyone will know what you're talking about. This is in the constellation of Canis Venatici, which are the hunting dogs, up very close to Ursa Major, the Great Bear. This thing is 60,000 light years in diameter. So, pretty big galaxy. Not as big as our Milky Way, about half the size of our Milky Way, but still pretty big. Contains 100 billion stars. Stars just like our sun. And it's 23 million light years away. So, this is something that isn't in our galaxy. This is outside of our galaxy, outside of the Milky Way. You can't see this with the naked eye. As I said, it's quite difficult to see in an amateur telescope. But with technology, this is the sort of thing we can do now. And I think you can start to see, hopefully, the swirling spiral pattern developing around the larger core. The smaller one you can see is getting a bit more fuzzy around it, and you should be able to see it'll end up looking like a big comma or a number 9, and we'll see that the spiral starts to connect the two. So I hope that's coming through all right. I'm getting red lights saying that the frame speed's dropping, so connection's not doing brilliantly. Hopefully you're getting enough up to, yeah, okay, it's picking up a bit. So as you can see, the image is starting to clean up quite a lot. Getting more and more detail coming through, and this is how astrophotographers come up with those fantastic pictures, and that's how, you know, Hubble's the same, no different really. They take like lots and lots and lots of pictures, images, and stack them. And by stacking them, what you do is you improve the signal of what it is you're looking at, and you get rid of the background, what they call noise. So you improve the good stuff, and you minimize the bad stuff, and that helps bring these images out of the background. So here it comes. You start to see the real wispy spiral going around the main two spiral arms going around the galaxy, and then this fainter link to the smaller galaxy. Periodically, this seemed to be dropping out the signal, but coming back. So I hope it's watchable. I know Lynn and Paul, you're still here because you keep giving me an update, which is fantastic. Thank you very much. Just looking at, dropped quite a few frames, but I really don't know what I can do about that. As it's the first time I've tried this, so maybe trying to do too much. We'll see how we get on. Okay, so that's the Whirlpool Galaxy. We could sit here for another half hour and see some more detail, but plenty of more things to see out there. So I'm going to try and have a look at another galaxy which is in a similar region to M51, but this is a much larger galaxy. So just stop that. So this is next door to M51, but this is actually in Ursa Major, and it's M101 it's called, also known as the Pinwheel Galaxy. Very, very large, beautiful spiral galaxy face on to us, so we see it at its best. Galaxies are pretty much just flat disks. So if we're looking at them edge on, there's not a lot to look at. They're just a thin bar of light across the sky. But when they're face on like this is, we see the full structure of them. Okay, it seems to be getting close. Target is centered. Very good. Right. Let's have a look. Restart. So nothing to see at the moment. Let's watch what comes out of the background. Okay, so there we have the real faint fuzzy core. So this is the one that's going to need quite a few images stacked on to bring it out. There you go, start to see more of it coming now. So this one's 170,000 light years in diameter. So that's even bigger than the Milky Way, which is about 120, 240,000 light years. This is 170,000 light years, a real giant. And it contains up to 1 trillion stars. So it's bigger in diameter than the Milky Way, and it's also got a lot more stars in it. It's estimated the Milky Way's got something around about 400 billion stars. This has got up to 1 trillion stars. 21 million light years away. So of course what that means is not only that it's an immense distance, it also means it's taken the light that we're seeing now 21 million years to get here. So we're seeing the galaxy as it was 21 million years ago, when of course there were no people on the Earth. And if there were, they certainly didn't have a telescope. Okay, so I think we just start to see the detail coming out of that now. The fuzzy core in the centre, where all galaxies tend to have a tightly packed core with a lot of stars. Usually it would appear packed around a black hole. Certainly the case with our galaxy and quite a number of other galaxies, and it's now considered that all galaxies have a black hole at the centre. This causes the stars to group tightly in the centre, and then you have the other stars. As you move outwards from the centre, you get the density gets thinner and thinner and thinner, and fewer stars. All galaxies spin. That's why we get these nice spiral patterns. improve the contrast here. This one. I think we'll increase the exposure. So we're on 10. I'll put that up to 30. Not a particularly bright object, as you can see. But a beautiful example of a spiral galaxy. So this is something that we are hoping next year to add to our stargazing. So I hope to be able to run a telescope that you can look through and see the object, and at the same time the camera will be in the background doing this live stacking. And then after you've had a look with the naked eye, you can then go and have a look at how the camera sees it, see more of the detail, and then we can talk about it, you know, the structure of things and the colours and that sort of thing. So a bit of a practice year this year to get the technology working. It's working not too badly. A few tweaks, obviously, and doing it in the field always brings a few problems, but trying to do it live as well over the phone hotspots, just adding a level of opportunity for error and failure. So out in the field it'll be much easier. We'll just run everything from a tablet, and we won't need an internet connection, and we'll be producing images in the background while everyone's having a look with the naked eye, and then we'll have a look at the images. So it's exciting. I think this is the future of stargazing. This sort of thing is becoming more and more popular. People are very much used now to seeing things on a screen. That's where most people get their information from. They look at pictures on their phone or their tablet, the internet. People are used to seeing Hubble images and things like that. So I think stargazing has to step its game up, and start presenting things the way people are used to seeing them. So yeah, it's great looking at things through a telescope, but there's always that little bit, I think, of disappointment that what you're seeing is generally something vague, fuzzy, or cloudy, and never really any colour. So M101's not coming out as well as I'd hope, but I hope you're starting to see the swirls, the clockwise swirls on this one, the core in the centre, and we're just starting to see that pinwheel effect coming. So I'll stick with it a few more minutes and see if that'll develop a bit further. you start thinking about the distances of these things are away. Start to think about the chances of ever travelling to these far off galaxies. It's got to be almost impossible, I would think. 21 million light years, so even at the speed of light, it's 21 million years to get there. I mean, why would you? It would take a heck of an effort to do that. It's going to be hard enough, I think, getting to the nearest star before thinking about getting anywhere else in our own galaxy, let alone other galaxies. But never say never, I suppose. But yeah, how many of those 100 or trillion stars in M101 have planets going around those stars? If we think about the Milky Way, every star has at least one planet. Probably all quite similar to us. We'll have quite a few planets. And there are billions and billions of other galaxies out there, not just the Milky Way. So, Milky Way has 400 billion stars in it. They've all got planets going around them. Every galaxy out there is similar. That's a heck of a lot of planets. It's a heck of a lot of opportunities for life. Okay, I think it's time to move on. Be nice to be able to sit here all night, but promised my neighbours I wouldn't be up too late tonight because it does make quite a lot of noise when I'm taking everything back in. So let's have a look at another nebula. So that was M101. Yeah. Okay, this is M27, sometimes called the Dumbbell Nebula or the Apple Core Nebula because it sometimes looks like, an apple core or a dumbbell. Astronomers have got great imaginations when they name these things. So this one's quite a bit larger than the nebula we looked at before, so quite a bit bigger than the Ring Nebula that we looked at. And this is easy to see in a telescope or even a pair of binoculars. So hopefully my telescope can see it, and we'll get a good look at it. No. Where he thinks it's going, but once again, it's gone the wrong way. So we'll get something to look at. Yeah, quite a bit of haze coming in at the moment, low down, so it's probably not helping it. Okay, that looks more promising. Okay, and I can see already there's a bit of fuzzy in the middle. So let's get going and start stacking some images. Yeah, so again, this is a nebula, and it's the same kind of nebula as the Ring Nebula. So this is caused by the death of a star that's lost its atmosphere, that's drifting off and creating this shape, generally circular, but because of the constituents of that atmosphere, different chemicals and gases that are in there, we see a structure that's shaped a bit like an apple core, some people think. So this one's in the constellation of Vulpecula, the fox. There we go. There we go. So quite a bit of colour around there. Some nice blue stars. Nice orangey star at the top. Quite a few orange red stars. And we've got this nice big nebula in the middle. As you can see, the colour, it's bluey in the centre with a red on the outside. So generally these nebula are illuminated by the radiation from the white dwarf that's left behind when the star dies. And the different gases in them will glow a different colour. So we've got different gases there that are glowing these different colours. Greeny sort of blue and bits of red. This is fairly close, 1,360 light years away, 1,360 light years away, 3 light years in diameter. So pretty big. But interestingly, not much bigger than the Ring Nebula in actual fact, but it's quite a bit closer. So it looks quite a bit bigger. That's one of the things of looking into space. You have to remember the 3D nature of looking out there. Just because a star is bright doesn't necessarily mean it's a bigger star than a star that's dim. It could just be that it's a lot closer. So these are some of my favourite targets, and the sort of targets that we would look to show people through the telescope. There are many, many others, of course, and I'll probably try this again in another week and have a look at some other things. And maybe in about 10 days, when the planets are higher in the sky, earlier in the evening, we might do something with the planets. I know Saturn's a great favourite of people, and obviously Jupiter's pretty bright. and when the conditions are good, that's really good to look at. So I would like to do something like that. Yeah, so there's that apple core sort of shape. Just zoomed in a bit there to have a bit of a closer look at it. Yeah, pretty pleased with the colour that we're picking up tonight. That was one of the things I was very hopeful of. And that's coming through quite nicely. So for any techies who are interested out there, the software I'm using ASI Air Pro to guide the telescope and do the capturing. And I'm using something called OBS, OB Studios, to do the actual presentation and streaming it over YouTube. I did try to do it over Facebook and I couldn't get it to work for some reason, but it seems to work really nicely with YouTube. It's something I hadn't heard of 2 weeks ago, so it's been quite a steep learning curve getting used to this, but it's a lovely bit of software. There's all sorts you can do with it, so I'm quite pleased that at least it is working really well. So that's really nice seeing that nebula, and I think just there in the very centre, can you see that? That's the white dwarf. So that white dwarf showing up quite nicely in this one. Because I'll be honest, I don't know for sure that's the white dwarf. I would have to check. But anyway, there is a white small star-like thing in the middle. Really nice. Really good strong colours around there. Those stars as well. That's nice. Okay, let's have a look for something else. Now there is a comet around at the moment that I would like to try and find, but looking at the way the telescope's been behaving tonight, it might be tricky because it's pretty small and it's a long way away. Well, actually, the comet's really large, but it's a long way away, so it looks quite small. So I think we'll try that now. Give it a go anyway. I think it's worth having a try for. So bear with me. This one might take a little while to find. Yeah, very pleased with that. On M27, that's come out really nicely. Right, here we go. So this is called Comet 2017 K2. Pan-STARRS in brackets is the telescope and observatory that actually found this first. So you see a lot of comets that have the name Pan-STARRS attached to them. That's a year it was found, 2017, and it's given a designation K1 because there was K2, sorry, because there was a one called K1 already found in 2017, and I think there was probably an A1 and a B and a C and so on. So, right, fingers crossed, because this would be a good one to find. Why does that say it's going to M27? That's not right. Go there. It's going to need some help again. So. So this one was closest to the Earth on the 14th of July, so it was 5 days ago. So it's reasonably bright. It's now heading in towards the sun. I'm worried it's going to be behind this building. Oh, it is. Don't think we're going to get it. Don't think we're going to get it. Let's just check. I don't think so. No, I don't think we're going to get that one. Unfortunately, it's just too low. It's too low in the sky now. That's a shame. It's just gone behind that building. Next time. Next time. Okay, let's have a look. Okay. Messier 20 or M20. The Trifid Nebula. So this is a nebula in Sagittarius. Now this is a different kind of nebula. This isn't from a dead star. This is giving birth to stars. So this is how stars form. This is how stars start. They start from a nebula. And then when they die, they go back to being a nebula. So it's circle of life, I suppose. But, circle of a star's life. Okay. Just wait for that to load, and we'll do what's called plate solving. The telescope will work out where it is in the sky, hopefully. And we can make sure the mount's aware of that. And then if it's got it right, it should then take us to the target. Okay, we've just lost the connection again, which is a bit annoying. Sorry about this, folks. Okay guys, for some reason I can't get connected again. So something's up. And really I'm running out of time to do anything like a reboot, which I think is probably what it's going to need. So I think I'm going to call it there. I hope everyone's enjoyed it, and thanks for sticking it out while we've tested this, see how we can do. And the next one will be better. So thanks a lot, and as I say, I'll be uploading this